Oh.
Wonder why the sky is blue.
Christian proposed an interesting question, but in order to understand why light or the sky is blue, we must first understand light waves, the colors of light, and how light travels in air. So first off, let's take a look at light waves. Light is a kind of energy that radiates or travels in waves. Light is a wave of vibrating electric and magnetic fields. The energy of the radiation depends on its wavelength and frequency. Wavelength is the distance between the tops of the waves. The longer the wavelength of the light, the lower the frequency and less energy it contains. So an example of an electromagnetic wave would look like this. Where the wavelength would be the distance from this top to this top. And the frequency would be the number of wavelengths per second. So now we're going to look at the different colors of light. Visible light is part of the electromagnetic spectrum that our eyes can see. Light from the sun or a light bulb may look white, but is actually a combination of many colors. The colors blend continuously into one another. At the end of the spectrum are the reds and the oranges. These gradually shade into yellow, green, blue, indigo, or violet. The colors have different wavelengths, frequencies, and energies. Red, for example, has the longest wavelength, and the lowest frequency and the lowest amount of energy. So the wavelength for a red, the red light would look something like this. On the other hand, blue has the shortest wavelength. That means it has the highest energy and frequency. The wavelength for a blue ray of light would look like this.
Light in the air. Light travels through space in a straight line as long as nothing disturbs it. As light moves through the atmosphere, it continues to go straight until it bumps into a bit of dust or a gas molecule. Then what happens to the light depends on its wavelength and the size of the thing it hits. Gas molecules are smaller than the wavelength of visible light. If light bumps into them, it acts differently. So our gas molecule, and in sky and the atmosphere, we'll call it nitrogen. And so, when light hits a gas molecule, some of it may get absorbed. Here's our light ray, absorbed. And then, after some time, the molecule will radiate or release this light that it had recently absorbed, and it will radiate it as the same color. The different colors of light are affected differently. All the colors can be absorbed, but the higher frequencies, such as blues, are absorbed more often than the lower frequencies, such as red. This process is called the Rayleigh scattering, named after Lord John Rayleigh. Why is the sky blue? The blue color of the sky is due to Rayleigh scattering. As light moves from the atmosphere, most of the longer wavelengths pass straight through. Little of the red, orange, and yellow light is affected by the air, so basically it acts the same as white light. However, much of the shorter wavelength light is absorbed by the gas molecules. The absorbed blue light is often then radiated back and often into different directions. So, blah, blah, blah. Whichever direction you look, some of the scattered blue light reaches you, and since you see the blue light from everywhere overhead, the sky looks blue.
I'm blue, I've been I've died, 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 I've been I've died. I'm blue, I've been I've died, I've been I've died, I've been I've died.
If the sky is blue, then why in the Sam Hill is a sunset red? As the sun begins to set, light must travel farther through the atmosphere before it gets to you. As less light reaches you directly, the sun appears less bright. The color of the sun itself appears to change, first to orange and then to red. This is because even more of the short wavelength blues and greens are now scattered. Only the longer wavelengths are left in the direct beam that reaches your eyes.
Red.